Okay, so I did record yesterday's, I recorded sixth period, they are posted, there's a link to the whole playlist in that top module of useful resources. And I say this especially because tomorrow is one whacked out day. I don't know that we're gonna get a lesson in on any class period. There's ninth graders come and have your assembly, 10th graders come and have your assembly, they're all different class periods. And then there's a something special first, and there's a something else special seventh, that everyone, yeah. So, so as I'm saying here, whatever disruptions, this is just review material. There's stuff out there for you to help yourself. You can check, Delta Math again, there's the videos embedded, and there are spelled out like solutions to each of those. There is this, the hard packet that we used to give out, blank, is posted as well as with solutions. And I'm going over them now, and I'll record whatever I do tomorrow, so if you get pulled out of here, we get shortened or something, there's that. And someone else asked about, so matrices gonna be on there. The matrices on the Delta Math, there's matrices, like, yeah, no. Anything that we've actually done, and take a picture for Nico.
Yeah, he asked me to.
Yeah, so it's Algebra 1, Geometry, Algebra 2, and Pre-Calc stuff that you've kind of seen already. And it doesn't mean it's gonna be easy. Okay, and all that said, also Friday is super happy fun welcome back to school pep rally day, so classes are gonna be a little bit shorter, just because every day this week needs to be messed up. Love it. I am trying to institute this early. Like every year I ask my old students from last year to come in on Wednesdays at lunch, hang out here, I bribe them with candy, to help tutor anyone that comes by. So if you are feeling uncomfortable with something in particular, come by at lunch today. There will be a few people that survived pre-calculus, or actually pre-calculus and calculus with me in the past. So if you wanna come by, today is an excellent day. Okay. This question. We need to solve for y, and there were some questions of like, why are you telling us through this coordinate? Well, what I've crossed out is there are two answers. But if I give you this, now there's only one, and I only wanted one. So first step, I want to get y by itself. So how do I get y out of the jail bars that it's in, or where it is? Exponentiate. So I'm going to do e to all of that, and e parentheses all of it. E and ln, there's nothing in between it, so this drops down. And it keeps the jail bars. They are still there. They don't just miraculously disappear. And then this is where we're gonna end up getting two answers. And because I don't have a lot of space, I wanna do the next step on this side. How am I gonna pull that exponent apart?
Multiply.
It becomes multiplied down low. E to the 3x times e to the ln 2. E to the ln of 2, room is 2. Okay. And again, before class started, I got this question of like, how do we jail bars, how do we get rid of jail bars? Kyle, if I tell you that, what do I know?
A is positive or negative.
So either A is 4 or A is negative 4. Claudia, how would I deal with this one?
It's y plus 1 negative and negative y minus 1.
I'm gonna do it this way. either y plus one is the positive of that stuff, or y plus one is the negative of all that stuff. And now solve for y. Either y equals 2e to the 3x minus 1, or y equals negative 2e to the 3x minus 1. And then there comes this little caveat that I added, needs to go through that coordinate. So which one goes through 0, negative 3? How do I tell? Ray, what do I do?
You plug in 0 for x and then see if y is equal to 0.
Okay, 0 for x, so does that make this whole thing become 0?
No, we said negative 2.
Okay. So lots of things. Often when you guys plug in 0, you're like, well, 0, it goes away, so they're both going to be negative 1. E to the 0 is 1, and then e to the 0 times negative 2, bless you, that's negative 2 minus 1 is negative 3, which is what we wanted. So this is the answer that gives us that coordinate. Plugging in here, e to the 0 is 1 times positive 2, 2 minus 1 is 1. So that's not the answer that we wanted. Other things, cosine of 0. What's cosine of 0? 1 is not 0. So be careful. Again, it's the details that are going to get you on. Any questions about the warm-up? Okay. We stopped around here yesterday doing these, and I asked you, like, warned you to be careful, don't divide by the thing. You will be throwing away answers, like dividing by sign. Oh. People do funny things. Don't cross sine 2x off with the sine x and get just 1. Yeah. And another, my famous example. You need to show work on most things. The quiz Friday, there's some things that are going to be multiple choice or short answer, and you don't need to show any work. Those are, you should get them or you don't. But if you show work, and your work is hoo-ha, and you happen to get the right answer, it's still wrong. This shows you have zero understanding of how numbers work, right? It's right though. You guys will argue, but I got the right answer. Oh my God, don't know how, but. And I have a student graduated like 15 years ago. I found another example, you said I wouldn't. Okay, 15 years of looking. Okay. Someone yesterday, before you guys left, asked about this one. We will encounter this kind of problem at least 5 or 6 times, and every time it will stump you. So hopefully we'll think about it. Anybody? Yeah.
Subtract the 1, so it's x squared minus 1 is less than 0.
Okay, what does that do for me?
You can factor it, so x minus 1x minus 1 is yeah. And then that tells you that x is less than or equal to negative 1 unless it's less than, yeah.
Well, when this is equal to 0 is when x is 1 and negative 1. What do I do with those now?
You can make like a range.
Okay. Pre-cal last year, rational functions. When we needed you to figure out is this rational function less than or equal to 0, we told you to find all the zeros and find all the undefineds and put those on a number line and test them. We're going to do that a lot in here. So we were just told find these values. I'm going to put, there are no places where it's undefined, so I'm going to put where does it hit 0? Negative 1 and 1. Okay, let's test Where does it work? I'm gonna pick 0, putting 0 into either one of these, but I'm gonna put it here. I get a positive times a negative, which is gonna be negative. Putting in 8,000, I get a positive times a positive. Putting in negative 8,000, I get negative times a negative, which is positive. Which regions did I want? I wanted the less than. So this is the region. Do I include the ends or not? Yes, include. Perfect. So that's one way to do this, is move things over, factor, and solve. Some of you will be like, okay, well, I don't know how to deal with inequalities. I'm just gonna make it an equals, do the same number line thing. Great.
Does it matter if we write the answer in brackets or not? Inequality?
I prefer brackets. AP exam will accept both. But another way to do this, since Algebra 1, you guys know what this graph looks like. You know what this graph looks like. Where are they equal? Most of you don't even need to do the math for it. You're like, oh, negative 1 and 1. Where is it less than? Where is the happy face less than the line? The little smileys. Negative 1 to 1. Okay, do you guys have questions or topics that you want to make sure we go over from Delta Math or this packet if you looked at it online? Or should I just like keep picking and choosing questions? Matthias is like, you pick. Y'all. Are you guys okay with the logs? Should we do, they're both 34. Should we do 34A or 34B, or you good? Exactly. Good, we move on. Thanks, Paige.
I think we should do them 34.
34 this one? Not 34 that one, 34 this one? Okay. Okay. First, do the logs have the same base? Okay. So if they have the same base, addition across becomes what operation inside? Multiplication. Okay. All right. Now I need to translate it from log form to exponent form. Natalie, how do I do that?
3 to 2.
3 to the 2 equals 4x. Cool. Not sure how far we got with the unit circle stuff, but you guys are okay with finding from 0 to 2 pi where cosine is a half? Yeah.
Can we do the other 34?
The other 34, okay. Are they all the same base? Yes, okay. And you guys said a second ago, addition across is multiply inside. And I have now natural log of blah equals natural log of stuff. What do you know about blah and stuff? They gotta be equal. So officially, we're doing E on both sides and they cancel out. However, before I go too much further, 1 does not equal -1, but once I do the operation of squaring it, they suddenly do. So be careful, right here, doing E to both sides, I might have created something that's gonna make an extraneous answer. So I'm gonna solve this, subtract 2x and add 3, x equals 8. I need to check, does it still work? What things are we not allowed to do natural log of? Negatives? Can I do natural log of 0? No.
No.
No. I can do square root of 0, but I can't do natural log of 0. Plugging this in, I get a positive, it's all good, valid. Finally fixed that typo, it didn't used to work. Okay? And what's the name? Christine Catherine. So, and then Cameron, Nathaniel, and Cecil, and Zach, and George, I guess I know him. Naomi, Kate, Constantine, Michael, okay, I know a few. Roman. Next, Eric. No. Yeah.
Alex.
Alex. Triggy business. I don't wanna do 37. Takes a lot of time. But you really are okay with unit circle? Whereas sine -3 over, -3 over 2? Okay, first of all, sine is negative in quadrant 3 and 4. Across from pi over 3 is √3. Whereas sine √3 over 2 at pi over 3, I want the pi over 3 in this quadrant and this one. So here, pi plus pi over 3. So, and this guy is 2 pi minus pi over 3. But I wanna make sure you guys can do restrictions. Oh my God, so much of chapter 2. This we won't see till chapter 9, but do you guys, have you seen this before? Sigma notation? What does the sigma mean? Sum, add up each, all the things in that list that we're generating. Computer science people, what is this n called? Okay, the 1 is an initial condition, but what is the n? Like in a for loop or a while loop or whatever they're calling it these days?
Iterator.
It's an iterator, an index, it's something like, so. So it's saying, put in 1 first for n, so 1 squared over 3, sigma you said means add, so it's plus. Does 1 equal 4? No, so go up by a whole positive 1 unit. It can't be 1.7th in line. Now n is 2, 2 squared over 3, does 2 equal 4? No, so we keep going. Now n is 3. Does 3 equal 4? No, so keep going. 4 squared over 3, add them together. Okay. Even function symmetric about what? Y-axis. And odd function? Origin, it turns around. So, what trig function is even?
X squared.
Cosine. And, when they're in a clique, what's the other most famous odd function? Sine. You can turn it upside down and it'll land on top of itself. Tangent is also odd, but sine and cosine are the cool kids. We're okay with equations alliance, geometry, finding slope, changing y over changing x. Don't do it upside down. And every year I point it out. I don't do this assignment anymore, but I ask students to graphically show concepts. Rise over run, the runner, the sun rises over, she's going for a run in the mornings. Rise over run, yeah. And look, this one, the tangentleman is equal to the slope, tangent is equal to slope, yeah. Ha, ha, ha. I love these. Tangent is sine over cosine, right? You guys probably don't know Seinfeld anymore. You ever seen Seinfeld? Hated that show. I lived in Long Island. It's not funny, it's real. Oh my God, those people exist. But this is Seinfeld and his co-star, so it's sine over co-star, or his name was Cosmo. Sine over cosine is a square tangent thing. It's a tangent. It's tan. Sine over cosine is tan. You're not amused. I love these. We will get to product flow. Cocoa beans and corn. Who would ever multiply those together? It sounds like diarrhea in a blender. But I will show you product flow because it's funny. There. I love them. Perpendicular, negative reciprocal slopes, parallel, equal slopes. Vertical lines, that's going to be x equals. Horizontal lines are going to be y equals. Where are they? Oh, rational functions. Domain, range, vertical asymptotes, horizontal asymptotes. Remember? One person's going, oh, no, don't remember. Okay. I'll do this. Adrian, how does it factor? Lourdes, do you have either one factored yet?
It really does. I can see more of the board.
See if you keep your rolls. You should like put it on the last one.
And then it just, like, it's like,
Factor?
That one.
Yes.
It's an X minus 6.
And you put it in, yeah.
Okay, so Evan says the top factors as x minus 1, x plus, or x minus 6, x plus 1. Do you agree? And the denominator factors to be x minus 6, x plus 3? Okay. So all this question asked was, what's the domain? So I didn't actually have to factor the numerator. So what's the difference?
Negative infinity to negative 3, and then the little u. Negative 3 to 6. U and 6 to infinity.
Okay, so Flair says negative infinity to negative 3, negative 3 to 6, and then 6 to infinity. And I hear people saying there's a hole. Where is there a hole? When x is 6,
7/9.
and then you plug in 6 to the leftovers. If you plug in 6 to up here, you're going to get 0 divided by 0, which you're not allowed to divide by 0. You know what? I can divide by 0 all day long. That is what calculus is based on. It's what we're going to do in chapter 2. Is we're going to divide by 0. We're going to find instant rates of change by dividing by 0. Cool. So today, 0 divided by 0, plugging that in, you guys said is 7/9. it's a whole, it's still not allowed in the domain, okay? Do I have any vertical asymptotes? Constantine?
Yeah, when at x equals -3.
Do I have any horizontal asymptotes? Michael?
If it's like the same ratio, that's just, or is it one match?
Yeah, what is the rule?
Isn't it?
It's a coefficient.
Coefficients of what?
Of the highest and lowest.
This one's y equals 1. So, if I look at this problem, highest exponent anywhere in the whole problem is x to the first. So, the x to the first coefficient is a 3, the x to the first coefficient in the bottom is a 4, that's my horizontal asymptote. Okay, I'm gonna change the problem. That's a squared. So, Jason, what's the highest exponent anywhere now that I've changed it? Squared. So, what is the coefficient of the x squared term in the numerator? The numerator doesn't have one, so what's its coefficient? 0. And in the denominator, like you said, is 4. What's 0 divided by 4? So, that one would have a horizontal asymptote of y equals 0. Gonna change it again. It's next to the 7th up top. Nathaniel, so now highest coefficient, or highest exponent anywhere is x to the 7th. What is the coefficient on x to the 7th in the numerator?
3.
And what is the x to the 7th coefficient in the denominator? Doesn't have one, so what's its coefficient?
0.
What is 3 divided by 0? Nothing, so does it have a horizontal asymptote? Algebra 2, they told you top heavy, bottom heavy equal. If it's top heavy, doesn't have a horizontal asymptote, it's got some kind of slant, which this would have an x to the 6th slant asymptote. Crazy. If it's bottom heavy, it's gonna be y equals 0. And if they're equal, you just take the coefficients, like Mayan said, it's gonna be y equals 3 over 4. Don't just leave a number, it's not 3/4, it's y equals 3/4, it's y equals 1, yeah,
Do you need to know how to find this line asymptote?
no, not yet,
Okay, thank you.
not for Friday. Chapter 8, I'll get you then, you got some time to get used to it. Does log have a horizontal asymptote?
Yeah.
Yes, no? No, Kelly's like not sure, he's shaking his head no though. Oh, now Kelly and Ray are both like, come on. I have a vertical asymptote. Where is the vertical asymptote? It's where the argument, where the stuff inside equals 0. Your vertical asymptote is at x equals 6. So the question actually asks, what's the domain? Domain of this log function are all positive numbers bigger than 6, not including 6. Preguntas? Question? I will pretend to speak foreign languages, I only speak English. But I try. No hablo español. Pero voy a tratar. Yeah, okay. Okay, people are still writing. Can I turn the page? Okay. These guys. these guys. Did I talk about trig inverse yesterday, restricted? I did in one class, not in here. Arc sine and sine inverse have the same meaning. Yeah. So that's saying what angle makes sine -1/2, but that it's capitalized, it's more explicit. It's saying, give me just one answer. Sine, you guys all know what sine looks like. It wiggles on forever. So asking where is it -1/2? Well, here and 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 here. I used to program artificial intelligence. It's like long before Siri and stuff existed. You'd ask it, do you know the time? It would go, yes. It's a polite way for us to say, what time is it? But no, if you ask the computer, do you know the time? It will just go, yeah. Do you? Like, so if you ask the calculator, when is sine -1/2, it could give you literally an infinite number of answers. And you don't want it to be like, well, on Tuesday, I'm gonna tell you 11π/6. But if it's raining, then I'm gonna tell you -π/6. You want it to always give you the same answer. Be like, you tell me that, and I will put it in the context that I want. So we restricted them in pre-calc. What is the one quadrant where the calculator is going to give us the answer for sine inverse where the ratio is negative? Fourth. Okay, I agree. So if it's positive, it's going to give you a first quadrant angle. And if you wanted the other one, you have to figure that out. Okay? Yes, fourth. The reference angle that makes sine 1/2 is π/6. So what angle is the computer or the calculator going to tell us? 11π/6? Or -π/6? It's one of those two. Which one and why? The -π/6.
Because it was closer or something.
Okay. Really, it's, when we're doing the inverse, there's this like window. It's gonna take from -π/2 to π/2. That's the real reason why. Like, otherwise, if you take the fourth quadrant angle, you're gonna be taking this chunk here and this chunk there. It's just uncomfortable and weird. I kind of explain it of, well, I live in Silver Spring. I am not gonna drive around the Beltway through Virginia, over a drawbridge on a major road around a big ass city to get home. I'm gonna go the short way. I'm gonna go -π/6. Just so much faster than the 68 miles around the other way. So restricted, the capital letters are restricted. Arc is the same thing as that negative to the -1. That to the -1 does not mean inverse, does not mean reciprocal. Arc tan of -√3. What quadrant does that come from? Tangent's negative in quadrants 2 and 4. Quadrant 4 as well, yeah? So is it, okay, what angle makes tangent √3? π/3. So is it gonna be 5π/3 or -π/3 is the angle? Also the short way, it's gonna be the -π/3. Cosine negative ratios come from what quadrant? Second? It's also negative in quadrant 3, but we're gonna take it from the second quadrant. So it's 3 pi over 4. Okay, okay, if it's a positive ratio, the calculator's always gonna give you a quadrant one answer. Sine inverse of a half, 30 degrees. Sorry, we don't speak in degrees in here, it's like blasphemy. And then it's the cost of doing business. Cosine negative ratios, the angle's gonna come from quadrant 2, this is the origin. Sine and tangent come from quadrant 4, and it's the little guy over there. Okay? So the capitalization just means restriction. And, yeah. You guys okay with that arc? Okay, Tam?
For 61 and 62, is it just the fourth quadrant
Yes.
answer? Okay.
And not just,
Oh, right, yeah, for 3 pi over.
just negative pi over 3. If you tell me 5 pi over 3, you are correct that they would be coterminal, they land in the same place, the bigger angle's wrong. Okay, tangent at 270. This one. What is it?
Doesn't exist.
Does not
Negative
exist?
1.
Okay, 270 takes us down here, that's 0, negative 1. Tangent is y over x, negative 1 over 0, undefined or does not exist. Cosecant 7 pi over 4, what quadrant does that take us to? 4th, so is it gonna be positive or negative? Negative because cosecant is what trig function upside down? Sine, okay. So sine of pi over 4? Root 2 over 2, this is gonna be that upside down, so it's just root 2. Cotangent 3 pi over 4? I heard 1 and I heard negative 1. Which one is it? Negative, because it's quadrant 2. All students take calculus. They're all positive here. Sine and reciprocal is positive in quadrant 2. Tangent reciprocal positive in quadrant 3. Cosine and its reciprocal positive in quadrant 4. Happiness and joy. Bell's gonna ring in like 30 seconds. All right, guys. Extra help at lunch today, and